First, let's examine the block diagram to get an overview of this circuit's operation before examining subcircuits and devices in more depth. The block diagram is a common tool supplied by manufacturers to give technicians just such an overview. When the push-button switch is pressed on either the front or back door, either of two identical latching circuits composed of IC1 are activated. These latching circuits are built so that the circuits operate for the full 16 beats for which it was designed, and then the latch resets. The output produced by one of these latching circuits enables a free-running clock, which is more appropriately called a beat generator for this musical type device. This beat generator, composed of transistors Q1 and Q2, along with a buffer transistor Q3, produces output pulses to drive integrated circuit IC2, a binary counter. The counter will sequentially express the number of each pulse in a 4-bit binary code. The binary numbers produced by the counter are decoded by integrated circuit IC3, which is a 4-input, 16-output decoder. As a binary number is input to the decoder sets the corresponding output to a low, while all other outputs remain high. This occurs for each of the 16 outputs in succession. In the programming section of the circuit, a melody has been previously programmed by the assembler. This was done by connecting the 16 outputs of the decoder into a resistor network in the tone generator section, which consists of transistors Q7 and Q8 and buffer transistor Q6. In this way, a specific tone can be produced in time with each beat. The tone generator output from buffer inverter Q6 drives a series of frequency dividers in IC4, a counter which acts as a subharmonic generator and a decay driver. The frequency dividers in IC4 produce square wave outputs at 1/8, 1/2, and 1/4 of the frequency generated by the tone generator. A fourth frequency divider in IC4 is used as a decay driver. The decay circuit Q5 is operating in its linear region as an analog device. This decay circuit causes the output to decrease during each beat, producing a natural-sounding musical tone rather than a clipped computer tone. This signal then drives audio amplifier IC5, an analog device, the output of which is then routed to the speaker. At the end of the 16 outputs of the decoder, a reset signal is activated and the latching circuit and the beat generator shut off. As you can see, the design of this programmable doorbell is very clear. A variety of devices can now be used to compose the various subcircuits in the unit. Also, as in many applications, digital circuitry is combined with analog circuitry. While you may be called upon to deal with any piece of equipment in its entirety, we'll concentrate only on the digital aspects of this circuit.